eyes up here for your next set of instructions. This is down 2 and 1. All right. A lot of you don't have a partner, so if you don't have a partner, can I go ahead and have you move up to this seat, please? Thank you. And can you move over here, please? And can I have you move over to that seat there? Okay. So we're gonna break it down into the 2 sections. So you guys have level 1 and level 2. So level 1 where you're solving for a variable, and level 2 where you're using input and output to solve an equation. Okay, so I want you to discuss with your partner. I'm going to count 30 seconds on my phone timer. 30 seconds, what you did and the answers you got. So if you and your partner only got to level 1, that's totally okay. Just explain to them what you did. So that's going to be our first 30-second segment that we're going to do. So you guys go ahead and turn it and talk. While you're talking, I do kind of want you to start incorporating these sentence frames into your answers when you're explaining your math answers. So for example, I already know in the second part that my first x variable is 0, so that I will then plug that into the equation. Just an example for you. So 30 seconds, turn and talk, go. All of it. All right, you guys close the conversations in 3. Eyes back up here in 2. Voices off in 1. Good job, thank you. Thank you. Okay. Now what I want you guys to do is if you got a different answer, I'll try to set the sound on here. I don't really understand my phone too well anymore. So what I want you to do in this next part of your turn and talk is you're going to, if you got different answers, you're going to try to agree on the correct one. Okay, so you're still using these sentence frames. It's just a little 30-second segment, and then we'll move on to kind of going over those as quickly as we can, right? So 30 seconds, compare those answers, and make sure you guys have the same one and try to agree on the same one, okay? Ready? 30 seconds, go. Oh, we got the same thing? You got the same thing? What about on this one? It doesn't look like you guys got the same thing at all. In fact, this is so different I can't even see it. Imagine that. It's okay. It's okay. So walk in through what you do. Alright, so our time is up for that one. So eyes back up here. We're going to walk through those really quickly. Can I just set this one? Okay. So in our first one, on level 1, we have number 1, x equals, I want to shout it out to me. I don't know. X equals 6. Okay. X equals 6. How did we get there? I want to tell me how we got there. Yeah.
What I did was I subtracted, so I put a line in the middle of the equal sign, and then I added plus 3 because it's the opposite of subtraction.
Okay.
And then I added 3 to 9 also, and then I got 12.
Okay.
And then I put down the 2x, and then I put that under 2, under 2x, and then I put 12 under 2, and then I divided it, and I got 6.
Okay, so you divided it and then you got 6. So what I heard was she understood that she has to move everything to the other side of the equal sign if she wants to isolate a variable. And we see our variable here is x. So I know I want to get everything away from that, and I'm going to start from the outside and move closer and closer as I'm solving, okay? What she did here, she added the opposites, she did the opposite operation, and that essentially gets rid of that, adds 12 here. When she said under 2, so she sees that 2 is held together with our variable with multiplication, she's going to want to divide that, so the opposite operation there, and 2 divided by 2 goes away, right, or gives us 1, and 12 divided by 2 essentially gives us 6. So over here, we want to know my first move. Some of you like to draw lines, so I'll draw a line for you for sure. My first move, I see that x is what I want to isolate. What do I want to move from x first? What's the furthest thing away from x right now? Yeah, 8. Okay, opposite operation of this right now that I can get rid of it would be to subtract. And I got negative 2x remaining equals 4. Perfect. Okay. Negative 2 and x are being kept together by what operation? What's holding them together? What did you say? Huh? What's holding them together right now? What's keeping them separate? Someone said it. Multiplication. So the opposite of that would be 2. Divide by negative 2. So this is the one that I did see the most difficulty with. So negative 2 divided by negative 2, that's going to cancel out. And then I have 4 divided by negative 2, which equals to negative 2. Cool. Okay. I'm only going to do this first one here so we can get on to our lesson point. But I want to ask you guys, when you see something like this, what do you know already? If you can, I know it's crooked, I'm sorry, I'm getting used to it. What are some things that you know already? Yes, ma'am?
That we're going to substitute 0 for x.
Substitute 0 for x. Why is she going to substitute 0 for x and not for y? Yeah.
So then it was like x is 0.
Okay, so I know that x is 0, and then on the side over here, that's representing y, do I know anything? No, I don't know. That's a mystery yet to be solved. But I do know one component of this equation here, so I'm going to plug it in where? Where does it go? Someone read out your new equation to me. I'm going to call on someone new. How about right here? Yes.
So I figured out what I got.
Huh? Not your answer. I just want to, we're writing our first part, so the first equation.
Oh, so times 0 plus 3y equals 18.
Equals 18. So here he substituted 0 in for the x variable. And so I have 2 times 0 plus 3y equals 18. When I multiply 2 and 0, we go ahead and get 0, or it cancels out. I'm not going to rewrite it. 3y equals 18. 3 and y are together again by multiplication, so I'm going to divide by 3. Divide by 3, y equals 6. Okay? So when I input 0 into this particular equation, my output is going to be 6. Okay? Do you guys want me to do one more, or do you want to move on? Move on. Okay. Okay. Appreciate your input. I'm going to start writing on the board. Okay, so our objective today and what we're working on is right up here. So can I have one of you read that out for us? Let's go right up here. It'll be really fun, I promise. Go ahead. Can't hear you. This right up. Is it in mathematicians? Mathematicians. Okay, so what we're doing is comparing rates of change. So when you guys hear rates of change, you should think back. So using slope and graphs and all the different ways that those will be represented numerically or algebraically. And we're comparing them. So we're going to get 2 different functions, and they're going to look a little different. So some language you're going to hear today that I'm going to read out to you real quick. So we're going to hear independent variable and dependent variable, which we kind of already touched base on a little bit earlier. Substitution. If I'm here, said substitution, whatever, I don't remember, sorry. Substitution, so when we're putting those variables into the equation when we know them. Relation, okay, can someone help me out with relation? Relation, set of coordinate points, okay, set of coordinate points. So when you see something with coordinate points, input and output, function, linear, and rate of change. The only functions we're looking at today are linear functions. So on our first one, that is your think about it. I'm not too sure how those are structured in class, so we're gonna, if it's different, I'm sorry. We'll get through the day though, just fine, I promise. What we're gonna do is I'm gonna put 5 minutes on my timer. It wants you 5 minutes on your own at a voice level 0 to try to work through. Okay, I'm gonna read it for you in case that helps you a little bit. So below are 2 different linear functions. So again, linear function, something changing at a constant rate between variables. Determine which function is changing the fastest using any methods that you have learned. And then you're going to move into justifying why the function you chose is changing faster than the others. Okay? So we have function 1 here, which is a table, and function 2 here, which is represented as a graph. So 5 minutes, independent work time, voice level 0. Come around and help you as needed. Go. Okay, just so below are 2 linear functions. Are we clear on a linear function? Good on that. Okay. Determine which function is changing at the fastest. Okay, so changing at the fastest. Method you want to learn. When you see a table, do you determine how? How so to change? You do. So as it moves from -2 to -1 to 0 to 1 to 2, it's changing how? How is this getting different as we move along the x? Beautiful. Okay, so find a way to represent that any way you want. And then this is, you're just finding what? If I want to know how a graph is changing over time, I can find the slope. Yeah. That's like what I went with, so I'm going to say yes. Where are you stuck? Where are you stuck? No. Where are you lost? Try and find this. Okay. So these are 2 different functions. Pay attention to the title. This is function 1 and that is function 2. Okay. So whatever I do here is going to be completely independent of this side. So if I'm determining which function is changing the fastest, what will we do? So let's pretend there's not even the word function, okay? Let's just throw that word away. We don't need it right now. I want to know how something is changing. So how this is changing, how this is changing. Okay, so how our table and how our graph is changing. So you guys have about a minute left. Great, so that does a minute. So I like reading it. You quit. You don't look like you're quitting to me. I think you do. So you can rock it back here. What's that? Okay, where are you? Okay, so let's start here because this is, you know, our easiest place. Talking to her, so it's fine. Okay, I want to know overall all these fancy words. I want to know how the function is changing. So I know a function can be represented as a table or a graph, right? So let's just ignore that. So I want to know change. Basically, that's the core of what I want to know. So when I'm looking at change, when I have x and y variables, am I more focused on the x or the y?
The Y.
The y. Okay. So I want you in the next 30 seconds to find out how this y values, how these y values, sorry, are changing. Yeah, that's right. All right, you guys, let's go pencils down. Pencils down. We're going attention and eyes are back up here. Thank you. Thank you, thank you, thank you. So I saw a lot of great work. We're going to walk through our changes in the functions first, and then we're going to talk about some predictions that some students had about which one is changing faster than the other. So we're going eyes back up here. Thank you. Okay. So if I have this first function here, what am I looking at? Okay. I want to know the change, right? I want to know the change in the function. If I have a table, there are two ways I can do it. Let's go here.
Find the slope.
I can find the slope. How? What's one way I can find the slope? Yeah.
By getting one x, well, two pairs from each value.
Any pair I want. Yeah.
If you look, x is usually going down by 1, so you just go down.
Okay.
one.
Good. No, perfect. That's a really important part that we're going to get to in just a minute, is we always want to make sure that our x variable is increasing or decreasing by 1 when we find a change, okay, especially when we want to compare them. So I heard someone say choose 2 points. I'm going to choose one, this one and this one here. And we know our slope equation is what? M equals? Huh? Where's yours? Huh? Oh, I don't want to know. I want to know just the slope equation first. So we had someone who says we're going to pull out 2 sets of coordinate points. We're going to solve it, but we have to have an equation to do that. What's our equation? You were working on the equation. What's our equation? I want to know what the variable. Sorry. What's our formula for it? A very basic formula. Okay. And then? And you chose 1, 1, and 1. So she actually chose those 2 points. She threw a curveball into my plan, which is okay. But I'm going to go ahead and give you the formula. So when we're finding change, or represented as a variable in, is y2 minus y1 over x2 minus x1. Okay? Something that I like to do that helps me keep these together is kind of label them. I'm going to use this as y2. I'm going to use this one as y1, x2, and x1. Okay? x2 and x1. When I plug those in, m equals 4 minus 1 over 0 minus 1. So m equals 3. Just 3? What's that? 3 or negative 3? What is it? Or slope or change equal? 3 or negative 3 on this side? 3 or negative 3? Negative 3. I hear a lot more negative 3, so I'm going to go with negative 3. So that's my change here. But since we're comparing rate of change, I'm going to represent it in a little bit of a different way. I'm going to put my rate of change equals negative 3. So that's my answer on this side. Okay? And another way, a shortcut you guys can use, is just look on this side how this is changing for, like, in between each variable, okay? So 10 to 7 is -3, so I can also go like this. -3.
Miss Sweet, I'm gonna pause you for just a second. I forgot that we have kids who earned a field trip, so we're gonna allow them to dismiss right now.
Okay, cool.
And congratulations, students who earned the field trip, great job. Have a great time. You guys are gonna trampoline jump and eat lunch somewhere cool. Maybe the rest of you should try to go next time. Okay, we're good, thank you.
Okay, we're good. Alright, so in function 1, I've done it 2 ways. I showed you guys using the equation. Or if you want to just visually calculate the difference between our output values. When I go into function 2, I saw a lot of misconception here. So I really want to focus, okay? So, 2 ways I can do this. What are the 2 ways you guys think I can do this? 2 ways. What's one? Throw out an idea. It's okay. Throw out an idea. How about, can I have an idea of how to do it? What do you think? Anything. There's like hundreds of ways we could probably do it, but we're going to focus just on 2. What do you think? Huh? I can find the points. That's a very good step, okay? So I want to know my points. I'm going to search for natural points, so where they're connecting at 2 intersections here. So I found 4 as x and 3 as y, and I know there's 1 going to be at 0, 1 as well. That's a very good start. What's another way I could do it? Visually. What do you think?
I was gonna say that.
You were going to say that? Once I have these points, what can I use? Is there anything on the board that you guys see once you have 2 sets of coordinate points that you could use? Anything you guys see? What do you think? You raising your hand? What about back there? Is there anything on the board you see that we may have done before where we have 2 sets of coordinate points to solve for slope? Going for someone new? I'm going to call you out. Yep. Anything already done? So, you got it. No, you got it. You can't see. So when I have 2 sets of coordinate points, I can use some tool that's been used before to help me solve it. You want to help him out too? His table partner? When your table partners, you either rise or fall together. So let's go. You got it. You got it.
Wait, what was it?
Huh?
What was it?
Okay, so if you guys aren't clear what to say, then you need to pay attention to the instructions. So I'm going to go here. Oh, another, okay. What can I use that's on the board to help me solve when I know 2 coordinate points? Maybe if I write them, that'll be more helpful for you guys. So 4 and 3. What can I use? See lots of hands, and now eat your hands. I'm excited to see that. What can I use that's already up here for you? And looking at you. What's this called? Slope formula. Okay, to find the slope. And slope is just a fancy term for how something is changing. Okay, I can do that. I'm going to go a little bit faster of a route personally right now because I think you're doing that in a different class. I think. So what I can do is I can draw a triangle from my natural point to natural point. Okay, so I'm going to go like so and meet up the lines. Okay, when I'm doing slope on a graph, I want to first look at my y, okay? So like when you stand up before you run. So rise over run, stand up before you can run, I hope. So I'm going up to here, and that's positive. And my x is moving also in a positive direction, so we're going over 1, 2, 3, and 4. So positive 4, okay? I'm going to write that as m equals positive 2 over 4. Again, rise over run. Sorry, I got it. This is a little low for me. But can I leave it like that? No, I really shouldn't also. So this could also be 2/4 also equals 1/2. So m equals 1/2. But remember, we're representing it differently because we're comparing our rates of change. Okay, so I want to write it rate of change equals 1/2. This is where it got really interesting. So your question is, determine which one is changing fastest. Raise your hand if you think function 1 with a rate of change of -3 is changing faster than function 2 with a rate of change of 1/2. Okay, we got 1, 2, 3, 4. You got half, you gotta go full, you gotta commit. Huh? I want you to raise your hand right now if you think function 1 with a rate of change of -3 is currently changing faster than function 2 with a rate of change of 1/2. So we got one hand here, one hand here, one hand here. So we got 3 of you, all right. Raise your hand if you think function 2 is changing with a faster rate of change than function 1. That should be all the rest of you at this point. Yeah, go ahead. All of it. Go on, raise your hand. Go on, because you did raise your hand before. You got to raise your hand now. Okay? So, we've got kind of split in the room, it looks like. Why, if you raise your hand and you think function 1 is changing faster, why did you think that? Why did you think that? You raise your hand. Why?
Because it's a bigger number, but with a negative.
Bigger number with a negative. That's a really good start. If you raise your hand for function 2, why did you raise your hand for function 2? Yep.
I said because it's bigger than -3.
It's bigger. 1/2. You're saying 1/2 is greater than -3 is what I hear. 1/2 is greater than -3. Well, you're definitely right about that. Okay. So, what does this negative sign in front of the 3 tell us? If we're thinking about change, if we're thinking about growth and decay, what are we thinking of? What does that tell us? Yeah.
That the rate of change is going down.
It is going down. It's going in an opposite direction, right? It's not necessarily expanding, but it might be shrinking, okay? So keeping that in mind, I'm going to tell you that I agree with the fact that function 1 is changing with a greater rate of change than function 2. Okay, that's how I feel about it, and I actually know, so I think we should follow that. Okay, so I know this because, okay, and we're going to get into our key point here, so make sure you're paying attention. -3, when we're thinking about change, has a greater magnitude or a greater scope than 1/2 when something is changing. So think about if you're depositing money. We'll use these 2 examples here. So if I deposit, let's say 50 cents a day, right? 50 cents a day, and grow 50 cents a day. But in my other account, I'm taking out $3 a day. Which account am I losing money from or gaining money from faster, right? That one that I'm taking $3 out. I'm spending more than I'm putting in, unfortunately, which is still like true to me also. We're gonna move on to the next point. I'm sorry, how am I supposed to do this again? Like this. We're gonna move on to our next one, where you guys are gonna use what we just learned there. We're gonna form our key point in that section of it. Keeping those parts in mind, our rate of change, thinking about our magnitude, okay? I'm gonna add something here for you, which I forgot, I thought it was on the next slide. 1/2 is greater than -3. But since -3 is making something change faster, we're actually looking at the absolute value of it, okay? So just the quantity of the number, not the sign that's involved in it. So the magnitude or the quantity. And a good way to remember that is how far away is -3 on a number line from 0? So, like I said before, another way to remember which one is greater than the other when you're talking about rate of change is if you put it on a number line, which one is further away from 0? Okay, which one is further away from 0? -3. Okay, so remember, rate of change, which one's further away from 0? Or you can take the absolute value of both. And when I do that, the absolute value of 1/2 is actually less than the absolute value of -3. Okay, so those are 2 ways to think about it. You guys are going to put 5 minutes up. I want you to approach the next problem on your own again, taking what you know. We're going to talk about it in 5 minutes. So at a voice level 0, get through that, go. working on?
I just got
You just got here. You gonna follow along the whole time? You were watching. Okay, so sometimes when we're watching, it's like easier if we write it down for ourselves. So I'm gonna let you do this, but I need to see some work on it this time. Okay? Especially if I do it up there. Got it? So in 1 minute, when we come back around, I need to at least see something down for this one. Okay. Okay, so you guys, I'm actually gonna stop you there for a second. Just go ahead, pencils down, pencils down, pencils down, pencils down, pencils down. Waiting on 4 for pencils down. Waiting on 2 for pencils down. Or are those just like heads are down? So I'm waiting on 2 for heads up. Yeah, there, that's better. Okay. I see you guys are having a little bit of a time getting started, and that's okay. So we're gonna read this together. Okay, you're going to talk with your table partner about what you think the problem wants you to do, and then we're going to go back through, then we're going to break down the word problem, okay? So, interaction with new material, 2 airplanes are flying in the DC metropolitan area. Airplane A's altitude is shown changing per minute in the table below. Airplane B is taking off and records their altitude at 1 minute at 1,450 feet, and then 4 minutes later at 6,050 feet. Which airplane's altitude is changing slowest? So as a table partner for 10 seconds, you're gonna turn to talk about what this question wants you to solve, okay? 10 seconds, turn to talk, go.
Yes, sir. There for me, and then 4 minutes.
Alright, let's go. Voice stop. Eyes back up here. You guys, good job. So what does this question want to know? And what do you know about this question? What does it want you to know? I haven't heard from you yet. What does this question want you to know? Yes, you. I'm sorry, what is your name, by the way? Okay, what does this want you to know, Preston? Which airplane is the slowest? Okay, that's good. What do you know? What information, key information, does this problem give you? We're gonna go right here. What's your name, friend? What's your name? Xavier. Cool eye, but what do you know about this problem? Nothing. Okay, maybe because what's that? Maybe why? What do you know about this problem?
That you give us a table for airplane A.
There you go.
And
So
give
it's
us a table for airplane B.
really cool, okay? So what I'm gonna do with you guys next is I'm gonna help you annotate your word problem, okay? We're gonna help you break it down into kind of like, I know this is getting into English, but our nouns and verbs of a word problem, which really helps us solve in math, okay? So understanding those components of it help us solve in math. So if I talk to you about your head being down, it shouldn't be down again. Thank you. Okay? Unimportant information I have here, 2 airplanes are flying in the DC metropolitan area. Cool. 2 is important, so I'm going to go ahead and box off my numerical values. Okay? Airplane A's altitude, which is the thing that I want us to kind of know, really important, is changing per minute in the table below. So changing per minute is important. That's what's happening to our thing, our airplane, right? So airplane B is taking off, and their altitude, which we're also looking at, is changing at 1 minute. 1,450 feet per minute, and then 4 minutes later at 6,050 feet. Okay, so I'm going to break those down in those 2 sections where I know airplane A is down here. It's all written for me. All the numbers I need are in that table. Airplane B, my most important numbers, we have underlined here. So 1 minute at 1450 feet, and then 4 minutes at 6,050 feet, okay? So once you have the annotations done, I want you to jump back into the problem, okay? I'm gonna reset the timer for you, and go. So we're missing, did you just round this number down? Okay. All right. I need to see some math work on this though. Do you know your rate of change here? What? You better write that for you. Rate of change equals what? I don't think you can answer that if you don't know this component here. Okay, so solve for the rate of change. If you're confused, you can always turn back and use your resources that we've gone over. It's very similar problems, okay? No, but can you tell me what you've already done so I can understand what you did? Okay, cool. Yeah, you definitely have the right slope. Can you finish simplifying it? I don't know. I'm gonna give up if you just write that close to the answer. Like that is the correct unsimplified numerical value of it. Okay, can we try to simplify that? Can you label your rate of changes? I don't know which one belongs to what or what this number that you boxed off means. Can you label it? Yeah. Okay, but can you write me out like rate of change equals? Oh, I know, that's what you're talking about. Where are you set? You don't know. 2,000 coordinate points. Really cool. What can you do with it now? It was something that we did before. We had 2 sets of coordinate points. Yeah, set that up. Keep going. Okay, what do you do? You have your equation. I'll stop there. show me your work for this one. Can you direct me where we're working here? Okay. So 3,500. I'm good. You made the choice of this one and this one. I think maybe if I'm looking at this, you used this point and this point, which this one is for the when x equals 8. So that's going to change your answer. So be careful when you're lining up your values. So see how you wrote it here just fine, but here you wrote it incorrectly. So like you had the right idea, you just got confused with rewriting them. Is that true? How did you get there? I know. Can you show me how you get there? So if you heard it back, then it'll be back.
Danny, are you okay?
That's good. You're yeah, yeah. Yeah, that's right. So is this what you're saying is your rate of change? Okay. Can you write that out? Rate of change equals this?
Well, I don't know if that's right.
I'm telling you it is.
Oh,
That's what it's going to be today, and you don't do that twice. And it just met you today. You don't, but you just don't know too long. Yeah. That's you close. I'm not gonna say it's right because it's not completed. No, it's not. What is your name? Yeah, you. What is your name? Tara or Tara? Katera. Perfect.
It's here.
Okay, so go ahead and stop there. I'm gonna have Katera come up for us. I'm gonna have Katera come up for us. Because she saw one of the airplanes change so beautifully. Okay, you guys, it's not free time to talk, even though it's a fellow student. So the one so tell them which one you did. Yeah.
Oh, okay. So, I know, I'm sorry. I'm gonna do, airplane B. Gabby, be quiet. Everybody be quiet, please. So, I'm gonna do airplane B. And so the numbers for airplane B was for 1 minute, it was 1,450 feet high, whatever. And then in 4 minutes, it was 6,050.
So go ahead and pause for just a second. There are a lot of you that don't have any of this written down, so I definitely shouldn't see you sitting there not writing when the answer is being written on the board.
I'm sorry, my handwriting is so busy.
There you go. Really?
Can everybody see this? No. Girl.
Why are you lying?
Can y'all see this for real?
Yes.
Okay.
That's the wrong name.
Okay, can I just, do I have to explain?
You can like talk as you're writing. That'd be great.
Okay, so 6,000, and 50 minus 1,450. You already know Mr. Halfaker does, change over Y is, and change over X, equals slope. So the change over Y, and then the change over X would be 4 minus 1, that equals 4 minus 1, 1 minus 4, or 4
whatever equals 3, and then this equals, and so what I did, since we don't have calculators at this point in time, at this moment, what I did was division 3, 4, 6, 0, 0,
And then just put your answer on top.
and then my answer.
She got 1,533. It's actually 0.333 repeating. But, so why did she divide? Before we move on into your exit ticket, I want to go over why she decided to divide it by 3. Okay? Why she decided to divide it by 3. And it's a point I mentioned earlier, which I'm going to reiterate right now for you. Do you want to go to track? No, you don't want to go track? Okay. So a point I mentioned before is when I'm calculating our rate of change, okay, which I do want you guys to work on representing like this. Rate of change equals, so I'm going to copy her answer down here. 3, 3. Okay, so that's my rate of change for that one. I want to break it down as x is changing 1 by 1 by 1. Okay, so when I read this, when I have 4,600 over 3, that's how much it's changing every 3 x variables, right, over 3. So I want to make sure it's down to the 1. Okay, so I'm going to go ahead. You guys are going to work on your exit ticket for the remainder of the period. I don't know if you can normally use resources, but yeah. So you can flip back to the things we worked on the first 2 pages, the new material and the think about it. Okay, and you have until 12 to 12, so about 7 minutes, I think, or less. Have fun. Go. Voice level 0. Yeah. No, because you had to borrow. So 10, I have to take. Yeah. Yeah, do that. It's in the class, so I'm like, sorry, to close it up. So we're on our exit ticket.